everybody. I wanted to walk through two possible approaches you could use to one of the more difficult test questions on our last test. Here with the question, we have the curve x cubed, and there are tangent lines to that curve at x equals plus and minus c, where c is just some real number. And those tangent lines have y-intercepts, and the distance between their y-intercepts is 4,000, and the question is what c value will make that happen. So the first thing that you want to do is help make sense of the problem for yourself, and drawing a sketch and labeling the sketch with all the important distances and quantities is a great first step. And I was happy to see that most people did something like that. So I'm going to do my own version of the sketch. So here's my x cubed function, and then I've got a plus c and a minus c, and I've got some tangent lines. And those tangent lines, I'm going to do my best to sketch them here. They should end up being parallel to each other. Something like this. And then here are their y-intercepts. Okay, so the first thing I wanted to note is a lot of people, your sketch misled you because the way you made your sketch, it looked like the y-intercept had the same height above the x-axis as the y value on the curve at c. So in other words, this dot was the same height as that dot. And so a lot of people immediately just said, oh, those look the same in my picture, so this height must be 2,000. So that's one thing that you want to make sure you don't do when you draw a sketch, is don't draw it in a way that causes you to make invalid assumptions. Remember that the whole goal is to solve for c. So c could be really close here, c could be really far over here, and depending on where it is, if you imagine the tangent line, you're going to get really, really different y-intercepts. So there's no particular reason to expect that the y-intercept here would be the same height as your y value there. So my second comment is a lot of people made this picture, but they didn't label everything that you could figure out about this situation. So I'm thinking this is 2,000 and this is 2,000. That's a relevant consideration. A lot of people never actually labeled this point. So you know that the x value is c, but you also know the y value because you know the equation. So the y value should be c cubed. The reason you want to label as much information as possible is because your whole goal is to figure out a chain of things that you can calculate that will take you from things you know, like this point, for example, and let you connect it with the thing that you don't know or the thing that you want to be true. So in this case, the 2,000 distance. So here's one approach to this problem. I'm thinking, all right, so if I only knew the equation of this line, I could figure out what its y-intercept was, and then I could set that equal to what I want it to be. I could set the y-intercept equal to 2,000, and then that would tell me the c value. So that set me an intermediate goal. Let's find the equation for this line L. So I know that I can find the equation of a line if I have the slope and a point. I already have this point here, and I know that the derivative will tell me the slope. So the derivative is going to be 3x squared. But remember, I want the derivative at a specific point. I want to find what's the slope of the tangent line when x equals c. So at x equals c, the slope of the tangent line is 3c squared. So if I'm going to write the equation for my line L here, I can use the standard template. So y minus a y value, so my y value here is c cubed, equals the slope times x minus a particular x value on the curve, c. So now I've got my line. And now let me think. The other point on the curve that I know is this one at 0, negative 2,000. So if I plug in negative 2,000 for my y value and 0 for my x value, that's going to give me this. And then this equation, notice it's only got c's in it, so I could solve for my c value here. So that's one approach. And if I were to try and characterize like what kind of thinking do you need to practice in order to be able to do this same thing in a very different problem, I would say make your diagram, label it with things that you know, and also label it a lot of people didn't recognize that you actually know the y value here because you're thinking c is an unknown. And in a certain sense, that's accurate, but once you've established that the x value is c, you could figure out what the y value was by plugging it in. So in a certain sense, you do know what the y value is in reference to the x value. So I'd say practicing labeling things in general like this is also going to help you. So another approach that is in general useful in math is describing a quantity in two different ways. Because if you can describe a single thing in two different ways, you know they're equal, and so you can set them equal to each other, and then once you have an equation, you can solve for something. So what I'm going to describe in two different ways is I'm going to describe the slope of this line. So I know the slope of the line using the derivative would be 3c squared, because I found the derivative of my x cubed, and now I'm evaluating that derivative at x equals c. Okay, well, what's another way of describing the slope of this line? I know I could describe it as this delta y over the delta x. So what is the delta y? I know this distance here must be 2,000 because it's the same as the y-intercept here. And I know that this distance must be c cubed because it's the height above the x-axis that this point is. So the whole distance must be c cubed plus 2,000. This distance here is just c because it lines up with the c value, which is where we're evaluating the point. So if I'm going to do delta y over delta x, that's 2,000 plus c cubed over c. And again, here I've got an equation that only involves c's, and so I could solve for c. Let's go ahead and do that right now. Maybe I guess I'll do it with both of them so you can see it comes out the same. So I'll multiply both sides by c, so that's 3c cubed equals 2,000 plus c cubed. So now I'll subtract a c cubed from both sides. So 2c cubed equals 2,000. Now I'll divide by 2, so c cubed equals 1,000. And then I'll take the cube root, and I get that c equals 10. Okay, let's try and solve for c up here. Looking at it, you can see this is going to come out much the same. So if I multiply this negative c in here, that gives me negative c cubed. I'm going to multiply the whole thing by negative 1, which will turn all of these positive. I'll subtract this c cubed, so now I've got 2,000 equals 2c cubed, and now it's the same as the other one. I divide by 2, and then I take the cube root, and again I get c equals 10. So two different ways to solve it. One way is find something that you can describe in two different ways, and then set those equal. A different approach is ask yourself, what could I figure out that would make my solution easy? So for me, I realized if I could figure out the equation for this line, then I could plug in the values that I know and solve for the unknown, solve for c. So it's all about kind of finding links from what you're given in the problem to what you're trying to figure out. And you can spot the links, or you're more likely to spot the links if you add labels to your diagram and you think about what various things do you have math that connects to.